Hello again, beautiful humans. A great presentation from Gil. Up next, we do have a last minute change, and which I think is exciting because we have Sudeep here from Traceable AI, and we're going to be talking a bit about improving security posture with API security. So thank you, Sudeep, for joining us.
It's my pleasure. Thanks, Jen. Very excited to be here at this virtual conference and talk about API discovery. I'm filling in for my colleague, who had a baby coming, is on the way. So, I had to jump in at the last minute. I'll try to do justice to his content. And essentially, we are going to talk about API discovery, how it is important from your overall API security standpoint. As the age-old saying in security goes, you cannot protect what you can't see. We've seen that with the public cloud recently. We've seen that with containers, and API security is no different in that regard. I'm Sudeep Padiyar. I'm a product management leader at Traceable. Been in the security industry for over 8 years now. Was at Palo Alto Networks doing cloud and container security prior to this. So would definitely like to talk about API security in the context of how the overall cloud native application security space is evolving as well. So the primary goal of this presentation is to actually help you understand, how important API discovery is in the context of security. What are the different aspects which a security engineer, which a product security persona or a developer needs to look at when it comes to APIs? What are the different aspects around the discovery? And how you can prioritize a lot of the findings based on some of those data points. And we'll also look at what are the features which are related to discovery that then make sure that your security posture around these APIs are more adequate so that your likelihood of a breach via APIs goes down substantially. So that's the goal for the presentation. Obviously, Traceable AI is one of the premium security companies which is focused on API security and discovery, protection, as well as analytics are the key ways by which we help our customers do that. So let's jump right into what are the challenges with API discovery, right? As in, if you look at how applications were secured over the course of the last 10, 15 years, what has actually changed, which makes APIs as a new attack surface, as we've seen with multiple breaches, in the last 3 to 5 years. So essentially, you can look at APIs as a mechanism by which your application functionality is exposed to end users. So what used to be a single monolith in the past, and that was eventually exposed either to mobile or web clients, is now exposed via REST or GraphQL APIs. Now, in that kind of a world, if you look at the three basic challenges which come in, one is with regards to deployments, right? Because now your APIs could be deployed in containers, in virtual machines, in Lambda functions, and they could be running in the public cloud. They could be running on-prem in your data center, or in certain scenarios, you have hybrid deployments where your front end is deployed in the public cloud, your backend databases or data stores continue to be in private cloud. So in that case, because you have a plethora of APIs which are providing this functionality, you don't always know where they are located, right? The second is, like I was referring to earlier, with regards to the microservices aspect of it. What used to be a single monolith now has hundreds or thousands of APIs. So ensuring that you are tracking all the relevant APIs which are part of the application that is accessed by customers eventually, and which of these APIs are external or internal, all of that becomes important. And the third aspect, as we've seen with CI/CD, with the agile release process, you will have new APIs which are released as part of this. And in many a scenario, it's only the developer who is working on that, who is aware that this functionality is being exposed as a new API. But everybody down the chain, whether it's end-to-end testing or the security teams, have not taken the adequate measures into account when they secure them, right? So that is why discovery becomes very challenging, and is one of the first things that our customers try to address when they look at API security. Now, in an ideal world, what should API discovery entail, right? As in, we heard about all the challenges, but what is the right way by which you can, get a visibility into what the APIs are, where are they deployed, what kind of data do they carry, becomes important, right? So there are two aspects, as folks are aware. One is the static aspect, which will come from your Open API spec, which will come, also called as Swagger files. So that gives you one mechanism. But as we've seen, in different aspects of security, as in the intent that the developers have, is not actually always mapping with what is actually happening when these APIs or applications are deployed, right? So the discovery should take the actual live traffic into account to provide an accurate view of what is seen versus what was the intention. The second aspect goes back to the microservices part of it, to the distributed application part of it, is how do you group your APIs by applications, by domains, by services, so that security teams can take the relevant measures into account, right? As in, if you're deploying your application in Kubernetes, then obviously you have other mechanisms around Kubernetes security that is important, that has to be done on top of what you're doing for API security. If this application is deployed in the public cloud and is in a certain VPC, which has certain controls, then those need to be taken into account for an end-to-end security posture. So that is where having a mechanism by which you can group your APIs, both based on the business logic and the functionality, as well as where those services are eventually deployed, that becomes important. And then, as we know in security, it's what is at the gate, what is public facing is always the first priority, to ensure that you don't have your hackers coming through the gate, and then you look at all the east-west internal APIs and third-party APIs to get the comprehensive coverage. So those are things that we will go through in detail now. So let's jump right in. That now that you have an API catalog, you have a mechanism by which you are looking at all the different APIs within your system. How do you make it actionable for the security persona, for developers, for product security? So we'll start off with the Open API spec, right? Like I was alluding to earlier, it's definitely a guiding light when it comes to what the original intention of the API developer is. It's a very good way by which you can get a good understanding of what are the intended data types, what do you expect to see in the request and response. So all of that is a good mechanism by which you can start off your posture. So if you look at how are the APIs being consumed, are they being consumed securely or not, right? If you look at the authorization part of your Open API spec, that will give you a lot of those information. Are the APIs being consumed as the developer intended, right? So now that a product like Traceable has the runtime view of this is the request response scene, these are the parameters that we've seen, you can then correlate that back with the spec to say that, hey, your developer intended this to be used in a certain way, but the actual application usage is different, right? And that brings in the security component of it, is that if your actual deployment types are different, then what does it mean from a security standpoint, right? What does it mean from a SQL injection or a cross-site scripting or a broken object level authorization standpoint? So those things become important, and your open API spec kind of augments what you see at runtime to be able to have the right posture. And then, are the APIs exposing unknown parameters, responses, content types, what is actually coming in the response bodies? Are they in line with what the request is asking for? Right? Is there additional information which can then be used incorrectly by the callers, right? So all of those things get pretty clear with the OpenAPI spec. So that is the common source of truth, and once you kind of correlate that with what we see in runtime, that becomes very powerful for our customers to be able to then either go back to the developers and say, hey, you need to change your spec, or in certain cases, the way the application is being written, or the way the backend is returning the data actually needs to be fixed, so that you don't have inadvertent exposure. The other is about portability. So that's an easy way by which, if we can export the spec from Traceable, for instance, then you can go back and use it in all your tooling, whether it's a Postman or other API tools that are used for understanding end-to-end how the APIs are being consumed. So the spec becomes the guiding light there. So let's kind of jump into the product to kind of give you an indication of a lot of the things that I was talking about. So this is the overall API endpoint view, right? So this is the discovery part of it. All of this has been done automatically based on traffic that we saw coming in through the different points where Traceable has been instrumented. So you see your API names, they give you a good indicator of, what is the functionality that API is exposing. Then the DNA is a concept within Traceable where, based on the different parameters that we've learned, based on whether, the data is sensitive or not, all of those help us in determining the composition of the API from a request response and detail standpoint. So now that the DNA is developed, you can look into the more advanced functionality, whether it's the sensitive data types, and I'll talk about that in more detail. But that is where things around compliance become important. If your API is suddenly exposing data related to PCI or PII or HIPAA, then your GRC teams actually have either an objection to it, or they need to be involved in approving that. So this gives you a very easy mechanism to do that. Similarly, around the risk aspects of it, how risky are these APIs? What are the kind of vulnerabilities they carry? If the conformance is not matching, then has it created anything on the posture? If it is not authenticated, but it's internet facing, then your risk is high. So all of those things become extremely important as you look at your overall API posture. The second aspect that I was talking about, the spec, right? So if you see, Traceable has actually created that open API spec based on the runtime data and the traffic that we saw hitting your different endpoints. So this open API spec is clearly telling you that, hey, in the request itself, you have different sensitive data that is going to be a concern both from the security and the GRC standpoint. Similarly, on the response side, what are all the different user roles associated with that API, right? What are the vulnerabilities? And this one is internet facing, but you have not encrypted it. What is the average call volume of requests, right? So that's a good indicator that if you get millions of requests on these specific endpoints, then the likelihood of a hacker or an attacker using that is also higher because it's in the mainline functionality of your application, right? So that's a comprehensive view that you get. You can then, as you can see in the top, you can rate limit some of those APIs, bring in the security posture, depending on a lot of these aspects that you see on the discovery side. So now that you see, what the native capabilities provide, how can you do this at scale, right? As in, If you've done the three major aspects around cataloging all the endpoints, you have open API spec for them, you have an understanding of what are the sensitive data types, what needs to be prioritized from a protection standpoint. How can you do this when you have thousands of APIs, right? Because that's where most of our customers are today, because all of the functionality that is released in newer components could be all APIs, right? So the first thing is around the conformance analysis aspect of it, right? As in, what was the original intent of the developer versus what is actually seen in testing or production. So that gives you a very good view on what the shadow APIs are, right? As in, some of these may not be exposed via your API gateways, right? They still need to be protected if there's a direct path by which either an end customer or your partners could be accessing that data. And we've seen numerous occasions, starting with Twitter very recently, where partners were inadvertently getting access to certain data via third-party APIs, and that then puts you at a risk of violating some of the privacy regulations as well as the conformance aspects of it. You could have issues with parameters, right? As in, you were expecting to pass an integer, but somebody is actually passing a string, and that now contains some sensitive information which the specific API is not handling accurately, right? So all of those aspects become important, because of which we allow our customers to create the spec from within the product and then download them, so that even if your developers are not using the Traceable product, they have a very easy way by which they can know what is the end usage of their APIs. So that conformance analysis helps in prioritizing some of the issues at scale. And then, we've been talking about sensitive data. I just want to zoom into that. Is around all the different categorizations, right? So it could be SSN, it could be email, it could be, especially in the public cloud, there are API keys from AWS or GCP or Azure. Credit card, essentially, we've seen numerous instances where if that information was expected to be only present in certain APIs which are going to a payment processor, but they are also accessible in others, then you have breaches coming out of there. So from an integration standpoint, you want to detect these as soon as you see them in your SDLC. So you don't want to wait till they get into production. So as soon as some of these get into staging, for instance, we have customers running Traceable to get a view of the new sensitive data exposure, and which API was it introduced in, who is the owner for that, so that your GRC teams can then take the necessary action. Your security teams can look at what are the implications for that. If it's violating certain policies, then that is a very clear indicator there. And then in terms of integrations, whether it is Slack or Jira, you can easily ensure that that information is relayed, is logged correctly, so that the relevant teams take action. And then you come back and you can verify that, hey, anything related to this particular conformance issue was actually fixed. And then you track it in prod and pre-prod environments. So this is a view of how we do it in the product. The data set, as I was alluding to earlier, a lot of the pre-canned data sets come out of the box, whether it is for materially sensitive information, whether it is PII or PCI. A lot of those come out of box, again, based on different geos. You will have different stipulations. We also allow our customers to create custom data sets if they're related to insurance or automobile or banking, and they have their own set of data that they would want to watch. Then you can do that automatically. Then the sensitivity around it, right? As in, how much of this eventually is critical, how much of it is highly sensitive. All of that becomes important. And this tabular way by which you see the total number of endpoints where the sensitive data is exposed, what are the end domains, all of that can be used to classify this information very easily. So now the key aspect, in terms of what does all of this mean from a security standpoint, because you want a single place where you can get a good gauge of what is the overall risk, what is the prioritization that I need to do on certain APIs versus the others, and that is what we do with the uniform risk score, which takes various different things into account, right? As in, is this HTTP or HTTPS? Is it a public-facing API? We spoke about sensitive data at length, but that is one of the key aspects where APIs are becoming an attack vector because you can exfiltrate data out of them. So what is the exposure? How do you map it to different APIs and different services where those APIs lie? And then the conformance aspect of it, right? As in, if your spec is deviating from what the developer originally intended, especially in areas which are important from the business functionality as well as from authorization or a security standpoint, then that's always going to have a higher risk score associated with it. And then that gets disseminated into the different options that I was talking about earlier with regards to being able to log issues on it, make it actionable for your developers and everybody in the SDLC, so that anything which is a highly risky API has the necessary mitigation plan around it. So in summary, these are the 5 key aspects which are important when it comes to discovery and inventory when it for APIs, cataloging, automatically creating the catalog, having the DNA, which explains all the different aspects around your APIs, and that has to be the starting point. The Open API spec, like we said earlier, allow a mechanism by which you create that within the product based on runtime data, which then allows you to look at conformance very easily. If there is a drift in different versions of the software, then you track it and ensure that your CI/CD mechanism or the tooling does ensure that if any of these are not intended, then you don't allow your subsequent phases of your SDLC based on that, and that makes it compelling, as well as has a very good gate for ensuring that you don't allow risky APIs to come in. Similarly, for sensitive data, the data flow aspect of it, having accurate traceability back into the request response where these sensitive data lie, and the APIs, which they map to, and then eventually putting all of this together into a risk score is how your complete API discovery can be done correctly. So that was the meat of the content. I would be glad to take any questions, Jen.
Thank you, Sudeep. And definitely one big question, because we are cutting it a little close to time. With yesterday, we talked to Phil Nash about supporting 10 million developers and being an evangelist, but also advocating. And one thing that it really is a huge question going along with that as well is, how can developers be involved early on in ensuring APIs are secure and advocate for it?
Sure. Yeah, no, that's a great question. And, it's obviously anything that you catch sooner in the cycle from a security standpoint makes it so much easier, both from the risk standpoint as well as the cost associated with any of these fixes. So, like we saw earlier in the presentation, mapping these back to the spec, right? As in, you have API endpoints, you see certain issues in the traffic flows, or you see certain security implications from the traffic flow. Then the key is to be able to map that back into the relevant APIs, and then the corresponding spec, which is tied to that particular endpoint, and then the conformance aspect of it that we were talking about earlier, right? So that very quickly tells you that, hey, the developer intended to use these particular parts of the request response a certain way based on data types or logic. But what is actually happening at runtime is very different, right? Because the sequence in which the APIs are invoked could be different, resulting in certain data being exposed. So how to do that in the prior, like in the testing or staging environments, becomes so much more important. And then you have to tie it back into the relevant services and APIs so that the right owners can then be assigned the task of ensuring that they look through all of this data and only allow it to go to the subsequent phases of their SDLC upon inspection and looking at the security implications there.
Awesome. Thank you, Sudeep. And we definitely appreciate you being a part of the conference, and great job on stepping in last minute. We, again, really appreciate your time.
Thanks a lot, Jen, and glad to be here at the conference. And if folks have any questions on Traceable, feel free to reach out to us.
Thank you.